welcome to another math tutorial. In this video, we're going to talk about absolute value inequalities. Now, we should already have some background knowledge of absolute value and also some knowledge of solving inequalities. And in this video, we're going to put those two ideas together and look at absolute value inequalities. So here we go. I want to begin with an illustration that will bring us to some understanding of what it is to blend absolute value and inequalities together. Now, in my previous video, we talked about absolute value equations, and this top statement says the absolute value of x equals 3. And what that means is that the distance from 0 on a number line is 3. And so here we see a number line, and we have plotted -3 and +3. Both of those numbers are 3 units from 0 on the number line. Now, if we replace the equal sign with an inequality sign, the meaning changes just a little bit. So if we replace the equals with a less than or equal to, so here our statement reads the absolute value of x is less than or equal to 3. Well, the equal to 3 still means the distance is equal to 3. But the less than means that the distance from 0 is less than, and then of course, or equal to 3. So what we have then is a solution set of values that are 3 units from 0, as we see there, or less than 3 units from 0. So like if I were to pick a number right here, that number is less than 3 units from 0. So we have all numbers between -3 and +3, including those endpoints, that would satisfy this inequality. Now, if I change my inequality to greater than or equal to, what we have is the meaning that says that the distance from 0 on the number line is greater than or equal to 3. And so here we've got still these points that are 3 units from 0 on the number line, but we also want to include values like this number out here, this number, that are greater than 3 units from 0 on the number line. Okay? Now, I show you this illustration to begin with because these number lines should look familiar to you. We have previously solved compound inequalities, and the solution, the number line solutions for compound inequalities look like these two number lines that we see here. So in fact, your absolute value inequalities are just compound inequalities. All right, let's take that a little bit farther and break it down into a little more specific language here on the next slide. Okay, as you recall from compound inequalities, there are 2 types of statements. You have your and statement, which is like an intersection or an overlap of 2 solution regions, and then you have your or statement. Well, with absolute value, the direction of your absolute value symbol indicates one of these 2 types of compound inequalities. If you have a less than or equal to, the less than is going to indicate that we have an and statement. And there's a couple ways that you can write that, and you can look that through, but we'll explain it in a little more detail when we do some example problems. If you have a greater than or equal to, whether the equal is there or not is irrelevant, but if we have a greater than, that's going to be represented as an or statement for your compound inequality. Let's do a couple examples of each of these so you kind of see how you're going to write and set them up and then subsequently solve them. All right, the first example says the absolute value of 2x plus 10 is less than 8. So first thing you need to do is consider the inequality that we have here. This is a less than indicates that we are going to combine these in an and statement. Now, there are 2 ways that you can rewrite this, and I'll show you both, and then you can decide which one you're going to choose. You can write this as 2 separate statements. You can write 2x plus 10 is less than 8, and 2x plus 10. Now on this second inequality, you're going to do two things. You're going to flip the direction of the inequality, so we're going to go greater than. You're also going to change the sign of the 8 to -8. So there's your two statements. You can write it like that, or you can combine these into a single statement. So I could write 2x plus 10 is less than 8, and my greater than side, I can throw it on the other end. I can say 2x plus 10 is greater than -8. And typically that's how we see the and statements written anyway, is to one long compound inequality. So I prefer to take my less than statements and rewrite them in this form right here. Now let's go ahead and solve that. We'll do a number line. We'll write the solution as well. So I'm going to begin by subtracting 10 to both sides. So that's going to give -18 is less than 2x is less than -2. We'll divide both sides by 2. And so I get -9 is less than x is less than -1. Okay, let's take a look at what the number line is going to look like for that. So your number line, you can be as detailed as you want, and that you can put a whole bunch of numbers on here. I'm just going to put -9 and -1 on the number line. Now we want all the x values that are less than -1. That goes that direction. And we want all the x values that are greater than -9. That goes that direction. So essentially we want all the numbers here, the overlap, all the numbers between -9 and -1. So our solution, non-inclusive of the endpoints, is -9, -1. Okay, next example problem. When I scan this over, a couple things kind of jump out at me. First, I notice that it's another and statement, as we have a less than or less than or equal to. The other thing that I notice is that there's a lot more going on in this inequality than the other one, and that there's more than just the absolute value on the left-hand side. Now, just like we did with absolute value equations, the first thing I want to do is I want to get just the absolute value part by itself. So that means this +5, I want to move over here. This divide by 3, I want to move over here. So I'm going to do those couple of steps first. So I'm going to begin by subtracting 5. So it's going to give me this absolute value of x plus 6 over 3 is less than or equal to 3. And I'm going to take that 3 and I'm going to multiply it to the opposite side. So I get absolute value of x plus 6 less than or equal to 9. So once I've done that, now I can go ahead and rewrite this as a compound inequality, and I'm going to drop the absolute value bars. And I'm going to put it into one long statement again. So it looks like this. X plus 6 is less than or equal to 9, and x plus 6 is greater than or equal to -9. So I'm just going to write both sides, both inequalities at one time. And to solve this, we're going to just simply subtract 6 from out of the middle onto both sides. So I get -15 is less than or equal to x is less than or equal to 3. My number line, again, I'm just going to put -15 and 3. That's a lot of tick marks between those two, and I don't want to be that detailed there, so that'll work. Notice that these inequalities have equal to on them, so we're going to do closed circles, and we want everything between those two numbers. So our solution is negative 15 to 3. Okay, we're going to finish up this video with a few greater than problems so we can see how they set up and work out just a little bit differently. The first one, I have the absolute value of 4x is greater than or equal to 8. So the first thing we notice is that we have a greater than or greater than or equal. It doesn't matter, but when I see one of those two, this is going to be an or statement. And I always remember this and kind of explain it in person in class is this is a greater than, and I kind of think it as a great or than. And so that kind of helps me if I sound it out kind of real specific like that as great or than. It helps me remember that when I see greater than, it's going to turn into an or statement. And then of course, if I don't see greater than, if I see less than, it's just the other one. It's going to be my and statement in that case. So here we go. Let's rewrite this. My first statement is going to be 4x is greater than or equal to 8. Or I want 4x. Now on this second inequality, just like we did with the and statements, we're going to do two things. We're going to flip the inequality so it's less than or equal to. And we're going to make the 8 negative. That's it. Now, when you have an or statement, do not combine them into two. Don't bring these together into two separate inequalities. And hopefully that's obvious why. Like, do not do this. Like, you don't want to do 4x greater than or equal to 8 and less than or equal to negative 8. Okay? Let's mark that out. Do not do that. And I'll explain why in the end, but for now, just definitely don't do it. Come back up here. If we divide by 4, we get x is greater than or equal to 2. Or here we divide by 4, we get x is less than or equal to negative 2. Now on your number line, so let's drop a number line. We just need negative 2 and positive 2. Because we have equal to, we're going to do nice closed circles, inclusive. So here we want x greater than 2. Greater than 2 goes out to the right of 2. And then less than negative 2 goes to the left of negative 2. Okay, now here's why I don't want you to do this. Okay, the way that this is written looks like the solution needs to be between your two numbers here. Because when you solve this, you're going to have x right between the two inequality symbols. And I think you're going to misinterpret that as shading between the two numbers. And so I don't want to make that, that confusion. So with your or statements, just do not, again, write that as a combined statement. Keep it separate so we can preserve the separate solution regions here. Okay, our solution then, we're ready to write. We've got everything from negative infinity to negative 2. We're going to include that. Or we want everything from 2 to infinity. All right, the next example problem. Again, I see a problem where I have absolute value. It's not by itself. I'm going to take this minus 7 and let's try a different pen here. We're going to take that minus 7. We're going to move it over to the opposite side first by adding 7 to both sides. So that's going to give me absolute value 3x plus 2 is greater than, shouldn't be an equal to, it's greater than 4. Okay, it's a greater than means that we're going to have an or statement. So I want 3x plus 2 is greater than 4, or 3x plus 2 is less than negative 4. Okay, subtract the 2. So we have 3x is greater than 2. Divide by 3, x is greater than 2/3. Over here, we're going to subtract the 2, so 3x is less than negative 6, and divide by 3, x is less than negative 2. Okay, so here's our solution. Let's go ahead and put that on a number line. So we need, on our number line, negative 2 is the smaller number, 2/3 is the greater number, so it's going to go to the right. And then I want open circles because there's no equal to, so open at both numbers. Greater than 2/3 is to the right of 2/3, and less than negative 2 is to the left. So our solution is negative infinity to negative 2, or 2/3 to infinity. Okay, one final example problem. Absolute value 7x plus 40 greater than or equal to 19. It's an or statement because it's greater than. I'm going to start by moving this 40 to the right hand side by subtracting it. So we have absolute value of 7x is greater than or equal to negative 21. Now when we did absolute value equations, when we got negative numbers like this and the absolute values by itself, we ran into problems and we weren't able to solve those equations. But with inequalities, you can, and I would encourage you, you need to play this out all the way to the end. We need to go ahead and solve this like we would and not worry about the fact that we have a negative right now. So let's set this up. It's a greater than again, so we're going to do an or statement. We want 7x is greater than or equal to negative 21, or 7x is less than or equal to, and we're going to change the sign so the negative goes away and becomes positive 21. So divide by 7, we get x is greater than or equal to negative 3, or, and here divide by 7, x is less than or equal to positive 3. Okay, on our number line, what does that look like? We're going to have 2 points. We want negative 3, positive 3. We want solid points at these values because they are equal to. So greater than or equal to, greater than negative 3 is everything to the right of negative 3. Less than positive 3 is everything to the left of positive 3. Now, because it's an or statement, we don't want overlap. We're not necessarily looking for intersection, but we want everywhere that the number line is shaded. And this number line happens to be shaded everywhere. You know, solutions are solutions that are in this part or in this part. And that just happens to be the entire number line. So how do we write an interval that represents the entire number line? We want everything from negative infinity to positive infinity. Okay, that concludes this video lesson on absolute value inequalities. I hope this helped you gain some understanding and how to solve absolute value inequalities. If you have any questions or comments, please leave them in the comment section below. If you liked this video or found it helpful, I would encourage you to give it a thumbs up to support the channel. Thank you very much.